Okay, so now let us do question number 23. This is an important question. It is for 6 marks. Okay, so prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. So here in this question, what you have to prove? You have to prove that the volume of the largest cone, okay, that is inscribed in a sphere of radius r. That means you have a cone inside a sphere, okay, and that cone, that volume is 8 by 27 of the volume of sphere. That we have to prove. And see, in the question they have said volume of the largest cone. So largest means we have to find the maximum. Okay, so let us start. So as you can see, I have drawn the figure. You have a sphere, and then inside the sphere there is a cone. Okay, so here the radius of the sphere is given, capital R. Okay, so this is the center of the sphere. Okay, and this is the cone A, B, C, D, and this is the radius of the cone. Okay, and this is the height of the cone. So here I have written, so this is the center, right? So from here to the circle, this is the radius of the sphere, that is given, capital R. Similarly, this also, it will be the radius of sphere, OC, that is capital R, and OA is also the radius of the sphere. And then this part BD, this is the radius of the cone. Okay, it is not given, so here I have considered X. And then this is the height of the cone, okay, CD, that I have considered as Y. Okay, so here I have written, let X be the radius of the cone and Y be the height of the cone. Okay, inscribed in a sphere of radius R. So here as you can see, this OA, OB and OC, they are equal, and they are equal to capital R, that means the radius of the sphere. And then CD is equal to Y, this CD, that is the height of the cone. Okay, and BD is equal to X, that is the radius of the cone. So therefore OD will be how much? See this part, OD. So if you want to find this OD, we have to subtract this OC, right, from whole CD, then we will get OD. So here OD is equal to CD minus OC. And what is CD? CD is Y minus OC is R. So OD will be Y minus R. Okay. Now as you can see, this is right angle triangle, right? You can take this or this, anyone you can take. So let us take this part in triangle OBD. Okay, so here we can apply Pythagoras theorem, right, to find this X. So we'll apply Pythagoras theorem and find X. Okay, so in triangle BOD, this is hypotenuse, so OB square will be equal to perpendicular square, that is OD square, plus base square, that is BD square. Okay, then what is a OB? OB is equal to R, so it will be R square equal to, and what is OD? OD is Y minus R whole square plus BD square, BD is X, so X square, or R square equal to, here I have used A minus B whole square formula. Okay, A square minus 2AB plus B square. Okay, this formula I have applied here, Y minus R whole square plus X square. Then we can cancel R square because both are same and of the same sign, so we can cancel. Then we will get X square equal to 2YR minus Y square, or only X square equal to, here we can take Y common, so I have taken Y common here, so what is remaining? 2R minus Y. So let us give this as equation 1. So now let us find the volume of the cone. Okay, so I have considered here, let V be the volume of the cone. So what is the formula for volume of cone? You have to know the formula. Okay, that is V equal to 1 by 3 pi R square H, right? This is the formula for volume of cone. So here I have written 1 by 3 pi, okay, R square. R square means what? Radius of the cone, right? And radius of the cone I have considered X, so it will be X square, and height of the cone I have considered Y. Okay, so in place of H I am writing here Y. Okay, so volume of the cone V equal to 1 by 3 pi X square Y. So now let us put the value of X square, that from equation 1. Okay, so V equal to 1 by 3 pi X square. See, X square, you got this Y into 2R minus Y. So in place of X square we'll put this value. Okay, so here it is 1 by 3 pi Y into 2R minus Y into Y. So we'll get 1 by 3 pi, then you multiply Y into 2R is 2RY minus Y into Y will be Y square into Y. that is equal to 1 by 3 pi. So now I have multiplied this bracket part with y. So 2ry into y is 2ry square minus y square into y is y cube. So we have got the volume. Now to find the maxima or minima, what do we have to do? We have to find v dash, right? That means the derivative, first derivative and then the second derivative, v double dash. So similarly we will find like that. So v dash is equal to, we have to differentiate this volume. So 1 by 3 pi is constant, you write as it is, and then here, so this r is fixed, okay, because this r is the radius of the sphere and this y is the variable. So we'll differentiate with respect to y. So differentiation of y square is 2y, right? So 2y into 2r is 4ry minus, and differentiation of y cube is 3y square. So this is the first derivative. Now we'll do the second derivative, that is v double dash. That means we'll differentiate this part again. So 1 by 3 pi is constant, so differentiation of y is 1, right? So 1 into 4r will be 4r minus differentiation of y square is 2y, so 2y into 3 is 6y. So we got v dash and v double dash also. Now to find the point, what do we have to put? We have to put v dash equal to 0, right? So for maxima or minima, so let us find the point. So for maxima or minima, v dash equal to 0. Now what is v dash? 1 by 3 pi 4ry minus 3y square equal to 0. So from here we'll get the value of y, okay? So 1 by 3 pi is multiplied here. If you bring on the right hand side, it will be divided. So 0 by something is 0 only. So we'll get 4ry minus 3y square equal to 0. Then we have to find the value of y. So minus 3y square equal to this 4ry we have taken on the right hand side. That is, this is plus. So if you take on the right hand side, it will be minus 4ry. And minus we can cancel. So and then here you have y square and here you have 1y, right? So 1y and from here 1y can be cancelled. So y equal to 4 by 3r. So we got the point, right? Now we'll check whether it is maxima or minima. So for that we have to put the value of y in v double dash, right? So at y equal to 4 by 3r, v double dash 4 by 3r will be how much? 1 by 3 pi 4r minus 6 into, so in place of y I put the value, that is 4 by 3r, okay? So after cancelling we'll get 1 by 3 pi 4r minus 8r, that is equal to minus 4 by 3 pi r. So we are getting negative, which is less than 0. So if it is less than 0, that means what? This is a point of maxima, right? So therefore y equal to 4 by 3r is a point of maxima. So we got the value of y. Now we have to find the value of x, okay? So from equation 1 we'll write this, okay, x square equal to 4 by 3r. So in place of y we'll put the value, okay? See, this is our equation 1, x square equal to y into 2r minus y. So in place of y we'll put the value, that is 4 by 3 pi. So we'll put the value here, 4 by 3r into 2r minus 4 by 3r. So here we can take LCM of 1 and 3, that is 3. So after solving you will get 8 by 9 r square, okay? So we got the value of x square, right? Now we need the value of y. Y we've already got, right? 4 by 3r. So now we'll put in the volume, okay? Volume of the cone. So here as you can see, volume of the largest cone, that we have to find, right? What will be the volume? So the formula is 1 by 3 pi x square y, I've already given in the first part. So now let us just put the value of x and y. So it will be 1 by 3 pi into x square. So x square is how much? We already got this, 8 by 9. r square, right? Into, and y is 4 by 3r. So after solving we'll get 32 by 81 pi r cube. So in the question we have to prove that volume of the largest cone is 8 by 27 times of the volume, right? So this 32 by 81 we can write like this, 8 by 27 into 4 by 3 pi r cube, right? Because if we multiply, you see 8 4s are 32, 27 3s are 81 pi r cube. We're getting this, right? And what is this? 4 by 3 pi r cube, that is the volume of the sphere, right? So we can write 8 by 27 into volume of sphere, okay? So that we have to prove.